All right, we continue with network and connectivity. So a collection of computers, generally we refer them as nodes, and transmission channels, also referred to as links, that allow people to communicate over distances. This is what we actually call a network or connectivity. Networks range in size from networks on chips to deep space networks, so distance really changes from millimeters to it can be thousands of kilometers. Connectivity is provided by a variety of transmission methods. So this is also something we see in our daily life. We have, radio communication, we have GSM, Wi-Fi, Bluetooth, and so on. All of this, actually, the ones I mentioned right now was wireless communication. But in wired communication, we also have many different methods. We have fiber optic cables, the classic Ethernet cables you use generally, but also, for TVs, you use a different cable and so on. So all of these are actually coming from technological advancements and, different transmission methods. So this is the topic that we are going to talk about, transmission methods. We will start with wired. So we will talk about coaxial cable, twisted pair wiring, and fiber optics. Then we will talk about wireless communication. We have microwave line of sight, satellites, cellular systems. But I will also talk about ad hoc networks and wireless sensor networks, because last week, remember, I told you that ad hoc networks might be a good solution in time of disasters, like natural disasters, like earthquakes and so on. So we will talk here about wireless transmission. So let's start with wired first. And the first one is coaxial cable. This is typical in cable TV setups. Operates as a transmission line since 1880. The first transatlantic coaxial cable in 1956. Popular in networks in the 1980s. There are two wires, copper inner core and outer conductor, to reduce interference from the wires in the environment. And this is actually looks like a simple sentence here, but historically it is important because initially when we are transferring electricity and so on, people didn't notice this outer conductor would be a nice idea. Because, for instance, if you are using copper as a cable, and if you don't use an outer conductor, there are too much interference. So you actually, if you want to use to transmit data hundreds or meters or kilometers, then without this conductor, actually you can only reach a few meters and so on. This is why people come up with different ideas. Instead of copper, let's say gold, because it is a better conductor and so on. So this was the physically people saw some challenges, but thanks to physicists, we have some outer conductor which prevents interference, and this is why we can actually can transmit data to long distances. So in the coaxial cables, the bandwidth capacity is around 1 gigahertz. So in order to transmit 1 bit per second, what you require is something between 1/14 hertz or 4 hertz. So the exact amount depends on modulation. Modulation is used to match a digital stream to the spectrum carrying ability of the cable. This is really important because how you transmit data through a cable depends on your modulation, and we need to use it because most of the time we are using the same cable to provide more than one communication to devices. Think about in the case of internet, for instance, in your apartment building, you connect your Wi-Fi router to the telephone lines via Ethernet cable, and you have the internet connection, but the whole building uses the same infrastructure, and from your apartment building, maybe there's only one cable leaving to the service provider, right? So that cable should allow you to connect. If you're, for instance, 100 apartments in the building, then it should allow 100 different communication to pass through the same cable, but allow all of them to communicate. So we will talk about this in a minute in more detail. So approximate carriage capacity is 8 gigabits per second. So we are talking about bits, but if you divide bit 8, it will give you bytes. So this allows you 1 gigabyte per second. So of course, this is the approximate carriage capacity. So this way you can have broadband access to the internet, TV cable connection. This is good because you don't need a telephone line. Most frequently used type RG6 for this cable, so the 1 meter is approximately $1. But this slide is a little bit old, and you're expecting to be cheaper nowadays. The second wired transmission method, we use twisted pair cable, lighter and thinner than coaxial cable. By the way, you can just Google and find nice pictures of these cables on the internet if you don't know what I'm talking about. But once you see it, you will realize that you are using it in your whole life. So in this twisted pair cable, two wires twisted together over their length. The twisted geometry reduces electromagnetic leakage. This is also referred to as crosstalk with nearby wires. This is really important. Because this way it allows long distances, like several kilometers. It is unshielded twisted pair since 1990s, and there are many categories for this kind of cables. And probably you heard some of them. For instance, when you use an Ethernet cable, you will talk about things like Cat4, Cat5, Cat6, that kind of stuff. So Cat5 is actually most of the time the one we are using. If you have an Ethernet cable, most probably it is Cat5. And actually it allows up to 1 gigabit per second. But Cat6 is more reliable because that is just a theoretical upper bound here. But here you can physically achieve that capacity almost all the time. There are higher categories like Cat8. It provides 40 gigabits per second. So you might say that why we are not using it, because Cat8 is designed only for data centers where distances between switches and servers are short. It is not intended for general office cabling, because in office cabling you can use, even in a building, you can use more than 100-meter cable like Cat5, so it wouldn't cause any problem. This is important because the cable actually determines your capacity. Think about USB cables. You're connecting a lot of USB devices to your laptop and so on. But if the cable is really long, like more than 5 meters, you will realize that it is not functioning properly. So this is why you should come up with solutions. And this twisted pair cable solution works really well so far. This is why we are using it all the time. Of course, let me check. Okay, it is not here, but we have infinite band in data centers for short distances, which allows you to have higher transfers, like 200 gigabits, 400 gigabits per second is something really achievable on data centers. And actually, NVIDIA has a data processing unit called Bluefield, and it allows you to have more than 400 gigabits per second if you use a special cable. And the port they are using, I think, called Connect X. And you can really achieve really huge speeds depending on the capacity of your cable. So the popular ones are now fiber optic cables. The highest data carrying capacity of any wired medium is around 50 terabits per second. I'm talking about fiber optic cables here. Silicon glass core that conducts light. Actually, you are now communicating using light. And if we look historically, in 1970s, we had slow computers, right? But the cables were fast enough to communicate, but the computers were slow. But recently, we have fast links, slow nodes. So okay, I have to say it. I said it in the reverse order. So the communication channels were bad. Think about our dial-up communication. We had 56 kilobits per second. And this is not really old history. I'm talking about my childhood. And during 1990s, we connected the internet using 56 kilobits per second, and this was, theoretical upper bound that you can use with your dial-up modem. And 56 kilobits actually means, like 8 kilobytes per second or something, right? 7 kilobytes. So it is really slow, but computers are more faster than that in 1990s I'm talking about. But now we have fantastic cables. As you can see here, you can transfer 50 terabits per second, but actually your hard drive is not even that fast to, produce that data and transmit it, right? So this is why now the technologies on the reverse order. Initially, I said it wrong, but now I'm correcting myself by notes. At the beginning, I said that we are actually talking about computers. So even if we have very fast computers, very fast hard drives, RAMs, and so on, it is still slow compared to the communication channel. This is why actually we can, use these channels with thousands of computers and, don't have a bottleneck. So electronic bottleneck, the mismatch between fiber link speed and nodal electronics, for example, computer speed. The data rate has been much higher than the speed at which standard electronics could load the fiber. There are two types of fiber, single mode cable and multi-mode cable. Let's look at the differences. In the single mode cable, the capacity of a single channel is between 10 to 400 gigabits per second. Single mode has higher data rate potential. It preserves pulse shapes more accurately, and it allows long distances like 80 plus kilometers. This is important because, in buildings or in a town, you don't need this much long cables, right? But you have to connect every town, every city with each other. So this is why you have to have this kind of cables. It should allow long distances. And actually, you might say that what happens if I need a longer cable, right? Because if the distance is like 200 kilometers, this cable most probably will not transmit the data in a correct way to the other end. This is why you have some other device which actually you put it between maybe every 50 kilometers and so on to recreate the data and transfer it again. So this way you can transmit data more than 80 kilometers away. But this is also a good place to listen to communication. And thanks to Snowden documents, we know that secrecy agencies recording every internet communication, and they can store the whole internet communication for a month. They have that enough storage, and they can also store the metadata of the whole internet communication more than a year. So this is why they need to use this kind of places to tap in and listen to communication. All right, but for the shorter distances, we can use multi-mode cables. This is a fiber with 100 channels, minimum 1 terabits per second. A light pulse is divided into multiple spatial paths or modes. Time is different between the modes in reaching the receiver end. This is how it allows more than one device to use the same cable. This is cheaper, but allows short distances like less than 2 kilometers. As you can guess, between cities, towns, we are using the single mode cable, and inside the town, we are using multi-mode cables.